All right, so we're going to start with exponential equations. What makes an equation exponential is when you have a variable up in your exponent. And other than factorials, which you're not going to get into, this is the fastest way for numbers to grow or decrease following a pattern. So we're going to look at graphing them, we're going to look at solving them. So first of all, if your base is improper or greater than 1, okay? So if your base is improper or greater than 1, it's going to increase. So it'll look something like this. That's your graph, and it's going to go like that. So it's really, really tiny along here, and then as soon as you start tacking on those values, so for instance, because it's kind of odd that I'm just yapping about this. All right, so if I have 2 to the x power, your base is 2. Your exponent is x. So there's a couple of points. First of all, is this improper? Yes, because it's 2 over 1. Okay, so he will increase as you move from left to right. The next thing to note is that every exponential function will travel through the point 0, 1 and 1, base, whatever your base is, unless you move it. Okay, so 0, 1 would be right here, not drawn to scale. Okay, and then 1, base. If I shove a 0 in here, any number to the 0 power is 1. So 2 to the 0 results in a 1. If I shove in a 1, 2 to the first will just give back what my base is. So when you're graphing, that's what we're going to go off of. If you have an elementary base or just an elementary fraction like 1/3, something like that, then we'll call it either elementary or proper. Okay, then it will decrease, but those 2 points will still be there. Okay, so as you read it from left to right, he'll start off really, really, really tall, and then he'll flatten out as we go left to right. So for 7.1, when we're solving these things, we want to make our bases match. And once we're there, because the left side would match the right side, then we can just manhandle the exponents. Okay, so those are our strategies here. So we're going to keep this pretty basic and straightforward. Okay, so what we have here is, and I'm just pulling this off of your homework. So, hang on, I have to yawn. Sorry. All right, so our base is 15/4. That is improper. So what do I know about an improper base? Improper will increase. So I know it's not this one, because this one is decreasing. Okay, as you read it from left to right, the graph drops down. But I do have this option, or this option. Well, do you see any addition or subtraction going on up here? No, which means your graph will travel through the point 0, 1, which is right here, and then 1, base. So 15/4 is almost 4. So there you go. So it's got to be this one. And if you'll notice, this one is nowhere close to being at 0, 1, and this one is nowhere close to being at 0, 1. So as long as you have a general idea, it's going to be pretty straightforward. All right, so on the next one, my base is 1/4 x. So my base is elementary or proper. So my function will decrease as I read it from left to right. I also saw that there was no addition or subtraction. And so that means that, hang on, there's no addition or subtraction. And so it'll travel through those 2 points. So here's a decreasing function traveling through 0, 1 and 1, base, which would be 1, 1/4. Okay. This one is increasing. This is decreasing, but they don't travel through 0, 1. So that again is your answer. So the next one is a little bit tricky because we have a negative exponent. So this says q of x equals 19/4 raised to the negative x. Well, I would like a positive x because I would like my this to be as straightforward as possible. So a negative exponent, whatever it's attached to, will tell you to put it in the opposite part of the fraction. So I'm kind of going to beat this one to death. This is actually 19 to the negative x over 4 to the negative x, because this power belongs to everything on the inside. Well, a negative exponent says to drop it where or to flip-flop its location in the fraction. So 19, instead of being in my numerator, should be in my denominator. And then 4, instead of being in my denominator, should be in my numerator. And then what's the trick? Both of those have a power of x, so I can just rewrite it as 4/19 raised to the positive x power. So in reality, what did you do? I just flipped everything on the inside. Okay, so back to what this means as far as graphing goes. I have an elementary or a proper fraction. It's not got any addition or subtraction, so that means he will be decreasing, and he will travel through the point 0, 1. So again, there we go. It is very, very straightforward. You should not have to wonder about any of it. None of them will be even remotely close. Okay, so again, this one, I've got a 1/2 to the negative x. That negative is freaking me out. So what did we just learn on the last one? The negative affects both the numerator and the denominator, so I'm going to flip them. I did what the negative says, so it goes away. And now this is a whole lot easier written just as 2 raised to the x power. So I have an improper base and no addition or subtraction, so it should be increasing. And it should travel through the point 0, 1 and 1 comma base. So here is, hang on, this is decreasing. You can't see. So it's not him. These are all increasing, but this is the only one that travels through 0, 1. Okay. And so the last one that we'll do, I think, for graphing, yes, is going to be 4 raised to the x minus 3. So if we have to translate any of these things, I made it pretty basic. Again, I tried really hard to keep these as basic as possible. So first of all, it is an element, or as an improper fraction, so he's going to increase. He should travel through the point 0, 1, but where did he go? So your rules from chapter 4 in transformations of functions are still in place. So this minus 3 is attached directly to the x. So if it's attached directly to the x, that's going to tell you a left-right. If it looked like this, then that would tell you an up-down. Okay, but this is attached to the x. This is a left-right, and always do opposite of what you think. So that means I'm going to move this thing to the right 3 units. So I'm going to look for an increasing function. So again, it's not him. Okay, could be. And then he should travel through 0, 1, but I shifted him to the right. So 1, 2, 3, so it's got to be him, because that one hits the graph. This one, he went 1, 2, not far enough, and this one he went up, down. So again, that subtraction of 3 actually means you shift it to the right 3 units. All right, so what am I going to do? For the last few, which we only have, just a few, hang on. All right, we may be able to knock this out in one video. I want to get my left and the right equal to each other. So I'm going to start writing on a different piece of paper. I've got 5 to the x minus 125 equals 0. And since we're solving this thing, normally what we do is we get everything on the left and then solve for x. Well, we're going to handle this differently. I'm going to get everything that contains an exponent with a variable on one side and get everything else on the other. So I'm going to add this 125 to both sides. So that gives me 125. Now your mission is to get the bases to match. So you have to remember that you're dealing with exponents. So we're dealing with powers of numbers. In other words, can I rewrite 125 as a power of 5? So 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. So I can rewrite 125 as something that means the same thing. It just looks different. And now the left and the right have the same base. So if I'm trying to make the left equal the right, I've got the bases already done. What you need to remember at this point is I'm going to just deal with the exponents. The bases are still there. I'm just too lazy to write them. So that means on the left, I have an exponent of x. And on the right, I have an exponent of 3. And now there is, holy cow, I almost dumped my Coke. All right, there is no more algebra to be done. And so your answer is 3. So in other words, 5 to the third minus 125 is 125 minus 125, which is 0. Okay, so you're finding the value for the exponent that'll make it true. Let's do a couple other ones. We had 2 to the negative x equals 8. And again, I'm going to try and make my bases match first. And this is already set up where I've got my variables and the exponents on one side and the constants on the other. So if I want to rewrite 8, remember 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. Okay, so I found a magic way to convert that 8 into a base of 2. So the left side stays as a 2 to the negative x. The right side becomes 2 to the third. So my bases match, grab my exponents, set them equal, and then solve. Well, on this one, x isn't by itself. So I need to divide through by a -1, or multiply through by a -1, and I get x equals -3. So 2 raised to the -3 would be a +3 equals 8. Okay, so you're finding that value that makes your exponent true. All right, so 2/3. I'm trying to squish this into one video. All right, 2/3 raised to the 3x plus 1 equals 4/9 raised to the 5th. Okay, so something, don't panic because there's fractions. It's the same process. Can I somehow rewrite 4 as a power of 2? Can I somehow rewrite 9 as a power of 3? Well, if I take 2/3 and square it, so I'm going to have 2/3 raised to the 3x plus 1 equals, this is 2/3 squared raised to the 5th. So in other words, 2 squared is 4, and 3 squared is 9. So ignore this 5 for a second and just rewrite that interior part. And now where am I at? My bases almost match, but I got to clean this up. So a power raised to a power means you multiply. So I've got 2/3 raised to the 3x plus 1 equals 2/3 raised to the 10th, because you're going to multiply. And now we're back in familiar territory. So your bases match. Now manhandle your exponents. So 3x plus 1 is 10. So subtract 1 and then divide by 3. So x must be 3. So 2/3 raised to the 3 times 3 plus 1 is 10. Is the same thing as 4/9 raised to the 5th, because that's 2/3 squared. Okay. I know that's kind of weird, and I know that there's a lot of 3's for answers in this problem, or in this section. All right, so number 10, we're going to dive in here. We got 2 left. Actually, number 9, sorry. So I have a 7 raised to the 5x minus 1 equals a 1/49. So your brain should be kind of tickling a little bit. Well, I know that 49 is a power of 7. I also know it's in the wrong spot. So let's get that to where it's in the correct spot. So I'm going to bring that 49 up top with a negative exponent. So that's an exponent of 1. Remember, I can change its location in the fraction by changing the power on the exponent, or changing the sign on the exponent, sorry. So I'm one step closer. Well, this is a 7, this is a 49. So 7 raised to the 5x minus 1 is 7 squared to the -1, because 49 is 7 squared. And now I've got a power to a power. So that gives me 7 to the -2. Okay. So multiply your exponents. And now my bases match. Grab your exponents and manhandle them. So I'm going to add 1. So 5x is -1. And then I'm going to divide by 5. So I get -1/5. Okay, so use what you know. As soon as you see that one's a power of the other, start rewriting in other powers. And then the last one, holy cow, I got 30 seconds. All right, so we got 10,000 raised to the -x is 10 raised to the 2x minus 4. So 10,000 is the same thing as 10 to the 4th. And this is 10 to the 2x minus 4. Can you see that? All right. So that gives me 10 to the -4x, because I multiplied my powers together. So -4x equals 2x minus 4. Hang on. There we go. And then solve for x. So I'm going to subtract x. So I get a -6x is -4. Divide by -6. And that gives me 2/3. So hopefully that wasn't too fast. But there you go. That is 7.1.